Finished studying organic chemistry? Let's have a look at this question. Which of the following statements regarding the molecule are true? It's a hydrocarbon, and it contains all kinds of bonds. The bonds are labeled. Let's go statement by statement before coming to conclusions. This is the correct style to approach these types of questions, especially when we do not immediately know what the question is really testing. Statement: all carbon atoms of this molecule lie in the same plane. Now, let's go to the structure. The best way to identify in-plane and out-of-plane atoms is to take hybridization into account. Let's label the carbon atoms as 1, 2, 3, 4, and 5. The hybridizations are carbon 1sp, carbon 2sp, carbon 3spi2, carbon 4spo2, carbon 5sei3. Now, SEP-SEP hybridization is linear and planar, so carbon 1 and 2 lie in the same plane. SEP2 hybridization is also planar, so carbon 3 is on the same plane, and so is carbon 4. Even though carbon 5 is sp3 hybridized, since it is connected to an sp2 carbon, carbon 5 also lies in the same plane as the rest. Statement A. All carbon-hydrogen bonds of the molecule are equal in length. From the first sight itself, we can say this is not true. Like I said, the molecule contains single, double, and triple bonds, meaning the carbons have different hybridizations. Therefore, the carbon-hydrogen bond lengths cannot be the same. One might argue that due to alternating pi bonds, delocalization occurs. However, even delocalization does not make all carbon-hydrogen bonds equal because sp, sp2, and sp3 carbons still form bonds of different lengths. Statement C. The carbon-carbon bond lengths increase in the order s^r. In simple terms, triple bond is the shortest, then double bond, and single bond is the longest. Now, to decide the length of the two single bonds, we must consider the hybridization of the carbon atoms forming those bonds. Bond P exists between sp3 and sep2 carbons. Bond R exists between sep2 and sp carbons. Since sp3 carbon has more p character, the bond involving sp3 will be longer. Therefore, bond P is longer than bond R. Statement D. 3 carbon atoms of this molecule are linearly arranged. Let's check. Carbon 1 and carbon 2 are sp hybridized, so they are linearly arranged. Carbon 3 is connected to an sp carbon, so it also lies linearly along that axis. Although carbon 3 is sp2 hybridized, the linearity exists up to 3 carbon atoms. On the other end of the chain, carbon 4 is sp2, carbon 5 is sp3, so there is no linearity there. Hence, exactly 3 carbon atoms are linearly arranged.